Hi, and welcome back from lunch. Am I too loud? Yes, no? All right. So let's talk about how we built Messenger.com. And if you don't know, Messenger.com is a full-page React application on which you can send and receive Facebook Messenger messages. Why would we build such a thing when you already have chat on Facebook? Well, when we launched it, we gave all the reasons in the press release, and they're still true. Something nice happened as a side effect. A lot of corporations, for instance, block access to Facebook on their corporate networks because they want people to be productive. But they don't block access to Messenger.com, at least not yet, so there's that. But also, we thought it would be very cool to build. And how did I get to work on it? I was just lucky. I joined Facebook right about the time it was started, and the web messages team pitched the project. I liked it, and I joined, and I never looked back. Before we get into actual Messenger.com, I want to take a moment and talk about how we front-end at Facebook. And I think it's time we use front-end as a verb. It's hard to talk otherwise. But as most companies do, we use modules, small components. This is the thing that makes sense. Everyone knows, everyone agrees, I think. How we make modules is the same as everyone else. We will define one, just messenger foo. It lives in the file that has the same name, messenger foo. We just add this doc block to the beginning of the CSS file, and we're ready to get started. We add our rules, but we have a special kind of syntax, as you can see. We use the name of the module, and then a slash, and then the actual rule name. This makes it very easy to, whenever you look at the class name, to know what it belongs to. And we have it so that you can only use rules and class names that belong to this module over here. So if we try to use messenger bar, this will be a lint error. Why would you want to change messenger bar rules from within messenger foo? We do this for encapsulation purposes and to try to make our CSS components small and very focused on one thing so that we can compose multiple if we need to. However, sometimes you do need to style something from another component, so we have a thing called public classes. We just define them in a way that you can use them in a different module, because sometimes you do need to style things differently depending on how you compose things. But this wouldn't really make a lot of sense. Why would we always overwrite the public class of another module? We just concatenate with our rule. It's very simple. It just takes some getting used to, especially with a slash in the rule name, which is not valid syntax, I don't think. But you don't even need to use all that. A simple rule like that is all you need for a module to exist. You don't even need a rule. You just need to put the module there, and everything will be public. And this is how we would use it in JavaScript. We have a simple mock messenger foo React component. We have an h1, and we want to just use the title class name on it. We just write React. Does anyone here use React? I'm sure you do. Yes, there we go. Put your hands down. But we can do more complex things. Instead of saying just use this class name, we can pass it some JSON. And in this JSON, the property names are the actual class names that we want to use, and the values are booleans, and they signal whether or not to include this class in the class list. And let's focus on the weird thing over there, that's CX. CX is our class transform function. It serves multiple purposes. For one thing, it actually evaluates the logic of which classes to include based on the Boolean values for JSONs. But it's always there. We always have to use it, so we know that we can search for it. And we look for instances of CX, and we find out which modules do we need to include. In this case, we need to include messenger foo and messenger bar, that's CSS, these two modules. And we do this not at runtime, because that would be very inefficient. We do this through static analysis at build time. We just parse all our JavaScript files, and we see which modules are being referenced. And then whenever the module will be loaded, we already have the CSS loaded side by side with it. It's auto-packaged and auto-required. And this is great because you never forget to include your modules. And this saves you a lot of time, hassle, debugging effort. And this enables us to do very cool things that have to do with the two modes. And I'm not talking about you read software more than you write software. Even when you're writing software or when you're reading software or code or when you're debugging it, you're still in the human mode. It's you interacting with the code that you or somebody else has written. The other mode is the machine mode. It's the machine when it executes your code and it has to do something with it, has to understand it. Our static tools, our static transforms and analysis allow us to do things that are good both for humans and for machines. For instance, this is all we need to type to get all the prefixes. These get added at build time automatically. And this is an optimization done for humans. It's very unpleasant to have to type these manually, as I'm sure you know. And you all use prefix-free or something of the sort. We go a step further. We also optimize for machine at this level as well, more or less. When a person loads our page, they load it with a browser. So if I'm using Firefox and I load messenger.com, why would I get the MS transform and the WebKit transform declarations? They make no sense. The browser will ignore them. They're wasted bytes. We actually don't even send them. We look at what browser you're using, and we only send you the rules that you will understand, which is very cool because this saves a lot of bytes, and bytes save energy. In fact, I estimated just by this thing, we save enough energy, which is equivalent to about half a Hiroshima every day. To put it in a different perspective, it's enough energy to warm up this room to a temperature of 214 cats for about a week. That's a lot. Another thing we do, and this is actually a pet peeve of mine, it doesn't matter if an element is 0 pixels or 0% or 0 elephants from the right. It's smack on the right. We don't need the unit there. We actually do remove it with static analysis. And this, again, saves bytes. Bytes save energy. This simple save, by removing the unit from 0, allows 200 stray cats to find a new home every single day. That's my estimation. And this munging is something we do for machines. Because I am a human, I'm sure you're human as well, most of you. And we need something like this. We need a rule that makes sense when you read it. This is the title rule belonging to the messenger foo component. A machine doesn't care. A machine needs a unique string. So why not make it something very, very short? A machine will do just fine, and we never have to read this. This just happens between machines. So back to our JavaScript example, this whole thing gets evaluated, and say we also have the subtitle. It will be those two classes. But this is after build time when this actually runs, so it's not that big, long string in the class list. It's just something small like this. Now, the compound savings from all these bytes are enough to boil all the coffee that has and ever will be consumed at all the CSSconfs that will ever happen. But we're not over. I mean, this is just writing and maybe debugging a bit. Yes, we're shipping code, we're shipping our code to the users and they're loading in their browsers, but we're not done. We have another thing. It's called machine learning, which we can use. We have this cool thing called Packager. And remember how we referenced 2 CSS modules in our example, messenger foo and messenger bar? Well, Packager will look at how messenger foo and messenger bar are loaded, especially in relation to messenger foo.js. And we'll see that whenever we request messenger foo, we also request messenger bar. So it makes sense to turn these 2 files into one single file. And the file name will also be very small. Again, fewer bytes and fewer bytes. And these are just randomly generated hashes. But even machines can make mistakes. 2 weeks ago or so, this file was generated based on Packager's heuristics. And I'm sure some of you already see the problem. Some people couldn't chat for a considerable amount of time because ad blockers thought this was an ad, when in fact it was just a couple of our modules that we kind of need for chat to work. Machines are silly, but that's why we're here. And here, today, yesterday, and just in general, people ask me a lot whether we use less or Sass and which one we prefer at Facebook, or do we use Stylus. We use nothing, because using one of these will make it harder for people who just start to get into the groove. Anyone who's ever written a web page can work at Facebook, and they instantly know everything they do need to know to be able to be efficient. We use plain old CSS. However, we do have the static analysis and static transform step in our build system, so we can do some funny things. We use variables, of course. We call them constants, though, because they're not really variable. And this is how you use a constant. What? It's a var. But anyway, at build step, we will replace it with its actual value. This is great, so you don't have to always remember, F06 for magenta. You can just say messenger magenta, and that will be great. Now, the rule that you have to use to, to go from an actual explicit hex value to a constant, or after how many repetitions do you use that, the rule, I still don't know it, but I'll find out and I'll tell you. But that's enough about how we actually, ship code. I think you got a pretty OK idea of what happens, hopefully. Otherwise, let's talk later. But let's get back to messenger.com. Because it all actually started a long time ago when we rewrote chat, the Facebook chat. We did this in a very special way. We thought, let's make some components that have no styling. They just get the data they need. And then we have different components that will present the data. This is not a new concept, but we decided to apply this religiously through chat. We call these style-agnostic components containers. And everything is a container, and it needs a presenter to actually display the data. So you wrap a normal presenter in a container, and you wrap that, a multiple list of them in another container, and so on. You go up and go up. We call this shawarma-driven development, because everything is a wrap. As a simple example, let's say we would hypothetically have a list of recent conversations. That will just call the style-agnostic thread list. We give it some parameters. We give it a presenter, which is something, again, we control. And we give it a class name just so we have a hook so we can use its public classes to style things. And we're done. It goes down one level. It calls the class, the component we pass in. And then again, for every conversation, we just add a new container, pass down the classes, have the hooks, and so on until we have the whole tree. Shawarma. And because this was a new thing, right? This Facebook.com, and Facebook.com has been there for a while, we believe that everybody should be able to use Facebook, so we support a large amount of browsers. But Messenger.com was a new thing, and by definition, it is niche. It's people who really want to use Messenger, and they want to have a nice environment to do so, a nice full desktop environment. So we decided to not support the old browsers, and that meant we could use the new CSS stuff. We were finally free to use Flexbox and stuff like CSS Grid for layout and whatnot, except we weren't, because we wanted to have something that looks like this, and with a CSS-only solution, it didn't work out that well. As Leah mentioned in her talk, just having a CSS-only solution doesn't help you. It's just so you can say that you have it, but it doesn't do anything else than be, and sometimes it's wrong as well. So instead of using Flexbox and CSS Grid, we went back to using an old component of ours. It's a layout component, and it is JavaScript-based, but it's battle-tested. We've been using this for a long time. We figured out the bugs. People who are much smarter than me fixed the bugs, and we shipped with this. And later, after it was shipped, when we had more time, we went back and found out what was wrong with Flexbox. It turns out that because Flexbox has changed so much over time, its its specification and all that, and the standard that it still isn't, we had some static transform rules that were conflicting with each other. And Chrome would sometimes get the new version of Flexbox automatically transformed, but Safari would get the old version with the WebKit box. And of course, that wouldn't work well. Well, once we figured out those issues, it was OK, except for Internet Explorer, because in Internet Explorer you still need to specify MSFlex 110 pixels. And it needs to have pixels there, because if you just say 0, it doesn't know what you mean. But remember our rule that strips away the unit from pixels? So we just added a couple of exceptions, and we were fine to go with Flexbox. Yay, Flexbox. But we weren't out of the woods yet, because it's a big product. Even though it sounds simple, it actually has very many moving parts. The shawarma wrap is very deep. And I'm sure you can see the problem with this. And if you miss it, let me blow it up for you. as you're typing in a right-to-left language, and you type in comma space as you do to add a comma, the comma just jumps. This is weird. We never understood why, and we spend a lot of time just debugging why this happened. We thought we were supposed to use some old, archaic components that we weren't including by mistake. But it turned out that it was our over-optimization. As many websites, as many web applications, we have just one font definition. It's a font family, we have a font stack, and everything's fine. We were using Helvetica Neue. And Helvetica Neue actually has this problem that if you're typing in right to left, and you're typing character, 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 comma, space, character, space and comma will just invert. And that looks very horrible if you're a user that speaks in a right to left written language. So instead of using Helvetica Neue, which is the cool thing, we detected if you're using right to left, we don't want you to have a bad experience, so we just fall back to Arial. Arial, the old boring Arial, but the old boring battle-tested Arial, which has been improved over time and works well with anything you throw at it. And this was just something that we just happened to find out. Helvetica Neue has this problem. But there are some things within Facebook that got in our way. JavaScript components really like pixels as size dimensions, as they should. But remember, we're a full page application. Pixels don't work well because you resize the page a lot. You might want to dock it to the left. And not only that, but we need to accurately display what you have sent to the other person with which you're talking. If you send them an image, we need to display it like this. But what if you send more images? Each case has a different grid and different sizing, and we need to kind of make it look nice. And if we try to stretch images, they will look horrible, and we need a different approach. Also, they're always about roughly half of the conversation window, even if they're 6 or just 1. In short, we need it to be responsive, and that's very hard to do if you're using pixels. So we had to add our own containers again, just so we could use different CSS classes that were based on percentages, and we couldn't use a lot of the building blocks that people on Facebook.com use out of the box because they only work with pixels. Still, though, we have 4 breakpoints. That's not a lot, but it is kind of a lot because it's 4, and we change small things at every one of them. The bigger thing that you'll notice is the right-hand side information panel. If we detect that you don't have enough space to confidently display it and also view the conversation, we'll just automatically close it for you. You can still open it if you want via the button. And again, as you expand and you have more space, we automatically open it for you. Actually, the day we released, we got featured on Good Products, as you do. And the person literally spent enough time resizing his browser window, back engineering what the rules for this are. And he was so impressed that we took the time to do this. But this is actually something very simple. It makes a big difference, but it's something simple you can do. But this is something that's very in your face. You can also be responsive at a smaller scale. Titles in Messenger, even on your phone app, they're centered. So we centered the page title, which is Messenger, but we also centered the conversation title. In this case, it's an unnamed group between me and 2 other people with long names. What if you want to dock your window to the left of your screen? Truncating centered text is weird, especially if you have icons on the other side, because they will take up space unevenly and will just look weird. And you can't use a CSS-only solution for this, because it's not dependent on the size of the viewport, it's dependent on the size of the name and the element that contains the name. And not even element query, if we ever get it, would help us here. For this, you need a hybrid solution. You need to measure the size of the text and measure the size of the container. And when there's not enough room, just change the class name, float everything to the left, and apply a truncation if you need to. Now, we do a lot of these small things on breakpoints or when we detect that you don't have enough space, just so everything sits nicely and looks nicely. It's supposed to be an app that's on par with the native experience, and that means you need to do a lot of these little polishings. And speaking of polishings and how titles in Messenger are centered, that's an interface guide. And we have an interface guide for Facebook. Now, please, Please, tell me you know what this is. Just say what it is. Yes, it's a fig, right? The Facebook interface guide, a fig. I showed this to Americans, and they just had no idea what it was. They had not seen figs. I went hot air ballooning, and the pilot dropped the balloon so we could just brush against some walnut trees, walnuts. And he said, if you reach out, you can actually grab some walnuts. So I did, and I grabbed the walnut, and it was all still green. And only me and the pilot knew that that's what walnuts look like. Americans are weird. They don't know what fruit looks like. In any case, that's the fig. That's the Facebook interface guide. And we have a different product. It's a messenger thing. So do you get the reference I'm trying to make? We have the MIG, the messenger interface guide. And that's just a visual style guide of how things should look like, different combinations and all that. Normally it's made by a designer. We found that it's a lot better to be made by people who are working on the product, not just the designers, not just the developers, but everybody involved. Because some things make sense to designers, some things are very cool to design to designers, but don't make sense to implement or just don't make sense for people to use. In any case, we took some of the Facebook components and turned them into our own components. Remember how when chat was rewritten, everything was a container and a presenter? That's kind of how we do components everywhere. We have an abstract thing and something that gives a presentation. And we were able to take the Facebook button, turn it into a messenger button, which looks a lot like a button. I know, I'm sorry. But you can see, Facebook on the left, messenger on the right, even though it's the same component underneath. And that's great because the Facebook components have undergone a lot of work to make them accessible. We have a lot of customization for ARIA roles and for screen readers to be able to properly detect them and their states. And we wanted to get all that good stuff over to Messenger. I want to take just a short time to emphasize accessibility. We need more of this. It doesn't matter if it looks good if you can't see it. You need to be able to use something. And another thing that's bad, also for accessibility, but just bad as an element, is my new favorite element to hate. It's the image tag. Now, let's go back to this example. The images here are, they're basically shawarmas, but they're each a different image, but we need to display them in a nice grid. If we would have a jagged thing, it would be horrible. If we display them one by one, it would take up too much space and use the context of your conversation. So we need to, size them evenly, which is not always possible with image tags, if you also want to make the images look nice. And then we have other use cases where if you share a link, we'll show you a preview of what that link is. And sometimes the link will have a thumbnail. In this case, yes, hot plug, that's me, I'm sexy. But I have a square image as my profile. Although over here is displayed in this nice wide ratio that we decided would look best for all images that are big enough to be displayed like this. But it's a square image being displayed as wide. But what happens if you don't have a big enough image? Well, we fall back to a different, more inline version. We just use the icon and we stretch it in a different way. You can't do this with images and live a sane life. So we just obviously use background size. We still have invisible images on top, so you can still drag and drop things, and we still have links around them, so you can open a new tab right there. So the accessibility layer is still there, but the presentation layer, what it looks like to people who can see, it's a lot nicer. And it's also something we control, and that is MIG compliant, the Messenger Interface Guide. And we do everything we can in CSS to make sure to set it up, and then we close the deal in JavaScript. Some things you can't do in CSS, like this, especially if you have a lot of dynamic data. And because we have these small, nice little building blocks, we can do cool things, like have interactive maps that respect our interface guide and respect the Facebook interface guide on Facebook. Look at the corners. They're all nice and rounded except for where the corners meet, up there in the top. This is also part of the interface guide, but you get this for free if you just use our components, because they're all very small and all do just one little thing. You can have simple attachments that just say, hey, here's my opinion. Or you can have nice, stunning-looking images that retailers would like you to still experience after you've left their shop, and you get notifications that says, yes, you bought this belt, it's on its way, great. And people who have built these things that aren't on our team tell us that they really enjoy building stuff for Messenger.com because of how easy it is to just use the small components that we've built. And the CSS is very small, but does its job very well. But that's not the best thing. The best thing that we feel that we've done is we were the first secondary domain. Everything you saw is basically Facebook code running on a domain that isn't Facebook. And they'll never be able to take that away from us. So do try Messenger.com and let us know what you think. We'll be here all day in the Facebook booth. Thank you.